which means a quarter of a semester is already gone. So a little bit on. And a few weeks later, it will be midterm exam already. So, and in terms of number of pages on textbook, we already covered several hundred pages. So it's your responsibility to read before and after the textbook. That is the best way to understand. Then do not rely on the PPT file. As I said, the PPT file is just a supplementary. Okay, it's not replacing of your textbook. Okay, so and also Wikipedia is also the point by point, the explanation or so textbook is the one of the compile the primary the material. So please read the textbook as much as possible. That is the best way to understand not only the operating system but any other subject in the college. So today we are going to, I don't think that we can finish the chapter 3 because we have the exercise lab regarding to the VI. Then, so if I cannot finish the chapter 3, we can continue on the Monday next week. The next week we will talk about the thread. However, thread, if you understand the process, the data structure, it will not be difficult to understand the thread. The thread will be quickly finish it. So I'm going to spend a little bit more time to discuss about the process. And today we have the exercise lab, the VI for the VI. So some of the students complain, do I need to know how to use the VI? I'm familiar with the Notepad and other, the Ultra editor or some graphical user interface GUI based editor. It's getting popular using the GUI-based editor, but still many of the systems they do not have, like as you realize in the GCP. So if you if you just develop the application program or app, so sometimes you don't have to, but most of the time you need to access the server side. Then at that time, if you are not familiar with the command line interface, it's very hard to use or there might be the workaround, but it will be very hard to fully utilize such a command or the facilities. So please to be familiar. VI is also a very powerful tool. So since the Unix was developed, it's 30, 40 years. And also once you get used, it's very hard to forget even. Still, I didn't use the VI last 12 years, or I think the third is longer than almost 20 years. But still, my finger remember the VI command. I cannot explain which one is which and how to yank, how to paste, how to jump to the page, but the finger remember such a thing. It's like when you learn how to swim or how to ride a bike, so your body, remember, it's a kind of muscle memory. So VI is the kind of the similar thing, it's muscle memory. So once you get used to it, it's very, very convenient. You may not use the editor. So, but it's the first time little bit weird concept. It has editing mode, it has a control mode, but because it's not the graphical user interface, there's no mouse pointer like that, only using keyboard. So, but once you got used to it, it'll be fun and very, very useful and powerful, especially when you are doing the system programming or the shell programming or the server side, the main management, like the administrator. Definitely you need to know how to use the VI editor. Okay, there are similar to such a command line editor, or like the Emacs or something other, but it's mostly based on the VI. So best way, use it. For the exercise lab and the project, please use it. You can edit and copy and paste also, but please try to get familiar with it. And also, for example, nowadays many of the company ask do something programming or do something during the interview. At that time, if you are familiar with the VI, so it looks like the professional, okay? Rather than copy and paste from the Notepad or other GUI editor. So now, if you do not know how to use VI, So do not ignore, just catch on. It's not that difficult, but need a little bit time, patience, and you will eventually get used to that. Okay, and also you can find a lot of the quick reference or some tip to use the BI. No matter what kind of material, it's fine. Don't purchase any the book or the material or the internet source or the online the whatever. Just the practice to use the BI. And as I announced on Friday, we are going to have the exercise lab for the GCP. It's optional, so if you are interested, so you can join. And extra exercise lab. During the exercise lab, we are going to do 3 or 4 exercise lab. That is already posted on the campus, but we cannot start from the activating the GCP coupon. But the prerequisite, instead, the prerequisite is you already activate and create at least one project. Okay, then we can start from the probably exercise lab 3. So lab 2 is just launcher, so you may not use right now. So we are going to start from the lab 3. The format is like it's not like the lecture. The GA and me will introduce what is the purpose of the lab. Then you are going to start the step by step. Then if you have any questions, so I try to help. The GA and me will help to address any issues. Then eventually you will get used to using GCP. The problem is I don't know how many the users can concurrently access the access point, Wi-Fi access point. When I check the number of access points, it's only 2 in that big room. So maybe around 60 or 70 concurrent user, but just in case, if you have enough the bandwidth of the data plan, please use your the data plan with the tethering. That will be helpful for you and the others also. And I try to reserve either this room or the other, but it's the whole day booked, so I cannot use this room and 107, 104. Okay, so homework, second homework is due on the September 22nd. Please don't forget to check your due. So today we are going to continue to discuss the data structure of the process. The last time we talked about what is a process, right? What is a process? Data structure, right? So data structure for what? To use computing resource. So we try to, the main purpose of operating system is to utilize the computing resource. So mostly it's a CPU, okay? So there are 2 types of the operation basically in computing. One is computation, okay, using the CPU. Another one is I/O, using input and output device. Your monitor is also I/O device, and also your keyboard is the I/O device. USB, the external disk, is also I/O device. So all of them are I/O devices. So we can roughly consider there are 2 types of operation. One is the CPU, another one is the I/O, the job, the processes. So to get such the resource power, the CPU would like to access the command, okay, that is coded by the user. But however, it is very hard to code directly machine the language, like the assembly code. Instead, we code using high-level language, like the Python, Java, C++, C, Ruby, Julia, whatever. So then compile, it will be translated to the machine language. Then that executable program is called passive the process. It's ready, but it cannot be executed by itself. Instead, CPU can access only memory address, something instruction on the memory. So, which means we need to move such an instruction that you compile into the memory. That is called the process. So, process is active program. Then, problem is just upload whatever the instruction. No, we need a certain rule. That is a data structure. So, last time we talked about the basic, the data structure of the process in the memory. So, there are full segment like the text, data, heap, and stack. This is a lower address. This is a higher address of the memory. The text is a copy of your program. Okay. Then the while data area keep the global variable that can be accessed by the any portion of your program process. Then the heap is going to this one. This is the dynamically allocated the memory space. So when you run your program, you need a certain space, right? Like the array or some variable. So the area will be based on the heap. On the other hand, sometimes you have the temporary variable or local variable that can be the used only portion of your process. Okay, so which means you from time to time, if you have unlimited the resource space on the memory, you don't have to worry about that. You can just allocate as much as possible or as needed. However, since you have the limited, especially memory space is much less than you need. Okay, so we need to optimize such a usage of the memory, which means some temporary use we are going to use a step. So step we don't have to worry about where the data is located, just the top of the step. Okay, last thing will be take up. So that is a step. So using this one, we can create the process. How to create, we will see later. Okay, before that, so how many such a process will be created on your operating system? One. Some of the operating system allow only one process, one job, okay, like the MS-DOS. But nowadays, most of the operating system allow multi-process. Several processes are running together. For example, this is the entire your memory, okay, like the 1 GB memory. So your operating system is also process. Do you remember the kernel? Kernel is the first process. Usually the process ID is 1, sometimes it's 0. Okay, we will see some of the example of the such a process ID in the operating system. So the init process is called the init process. Is the process ID 0. This one creates the number of the other process like the kernel thread. So starting from the 1, 2, something like that. But mostly the kernel process it starts from the init, okay? Then it will create. That is operating system. This is also process. Then whenever the child process created, it will be. So this is one process. There is another process. And another process like that. That is your current status of the operating system. Then problem. How many of the processes will be running concurrently? Which means how many processes does the CPU take care at the same time? Only one process at a time. Okay? So which means, let's say that this is the CPU time. We cannot stretch out the CPU time. We cannot reduce the CPU time. CPU time is a time. Okay? So which means even though we have the very powerful, like the brand new processor, like the CPU, their time is the time. Okay? The problem is how can we support the multi-process? How can we process the multiple processes? We need to slice the time. Okay? Then first time the process 1 and process 2 and process 3 or process 1 again and something like that. So we need to give more chance to the each processes. So which means we cannot increase or we cannot make another CPU unless we physically add a new processor. Instead, we try to maximize the CPU time, CPU utilization. So how can we do that? At the time we need scheduling. So operating system use basically if we have unlimited resource, like we have unlimited CPU time, unlimited memory, unlimited the bandwidth, we don't have to worry about the operating system. Operating system will be very simple, okay? So like less than 100 pages. So we can just address the synchronization. Yeah. And we can assign as many CPU, as many the memory as possible. However, unfortunately, we have very limited resource computing power. Okay, not only because of the money, but technically it is not possible to provide unlimited resource. So always we try to optimize plus fairness. So we need to give the same chance. However, fairness is not the uniformly distributed the utilization. We need to consider several other factors like the priority and so on. So this is a scheduler. So there are different types of scheduler in the operating system. So we will see today what kind of scheduler and the details of the scheduling we will discuss in the chapter, like the chapter 5 and so on. So first thing we need to consider is which process will be selected to the memory. Okay? Which process? This is not brand new operating system. This is not the brand new computer. It's very limited. Like it has 1 megabyte only. So we have several programs. Some of them are 500K or 200K and 300K. So if we learn the load of these three processors, it will be already full. Nara and Shule, can you discuss? I'm sorry, do not bother the lecture. So these are the full of the memory. So which means the operating system select the next time. The first time, which one will be selected, and which one will be selected, and which one will be selected. Okay? Process by process. So if you remember the process state, so do you remember that this process state? The new is started, and this is ready, and this is the running, and this is terminated, this is a wait. So first step, for the new process should be selected. Nowadays we click, or the type the command. Okay? That means there's no such a scheduler to select which process will be selected. The reason is that nowadays we pretty much enough the memory, okay, to load not the 100%. We can it's not unlimited the memory resource, but pretty much we have enough the space. So if possible, we don't care such a selection first step. Instead, whenever you just execute, whenever you just double click, it will be a new process right away. However, a long time ago, what the sum of the operating system? First, for the selection, these are the program. For the selection of the program to be loaded into memory, we need to select which process will be selected. Sometimes in your mind you have such a selection. I'm going to start the Microsoft Word, then I'm going to start the project, the operating system project, the coding, and so on. So in your mind you select. But long time ago, when we have very limited resource, even operating system has the selection process to be selected and loaded into the memory. That is called the scheduler. Especially that is called the long-term scheduling. So long-term schedule, once it is started, it will be host, okay, to the terminate, right? Once it is selected, it will be ready and running and wait and running, wait, running, eventually terminated. So it will be hard to take out such a selected process. So because of that, it's called a long-term scheduler. And also, it's not such a selection process will not be done very quickly from time to time. How often do you select the process program? From whenever you need, like the several minutes or the 10 minutes, not the every second you select the program. So that because of that, it's called the long-term process. There's another type of the scheduler. That is, so once the program is selected, like we have the, you remember the ready state. How many processes are in the ready state? Several processes. Like think about when you try to meet the Professor Lee. So you are waiting outside of my office. If there are many students, you may form a line, like the queue. So this one, the running state has a running queue. So we have process 1, process 2, process 3. Even though this is selected by this scheduler, but it's not in the running. Instead, waiting for to be selected, okay, in the ready queue. So this selection process is called another scheduler. It's a short-term scheduler. Why is it called a short-term? The CPU time, when we slice the CPU time, what will be the unit of such a slice? Minute? Minute is too long. So second, even 1 second, 2 seconds, you may not wait until several second response time. Instead, this unit is millisecond level. Okay? So millisecond means power of -6 level. Such a short time. So every millisecond it will be changing. Because of that, you may not realize whether the process is changing. This one, it looks like the running same time. Okay? So human being, so ours, the sensitive is not actually the very high sensitive. Our sense, like think about the video. Everybody knows video is. It's a frame, number of frame. So if you have the HD, the TV, how many frames? 60 to 120 something. The frame image is changing. Do you realize such a change? Even the SD quality, standard definition, the TV, it has the 16 or 32 the images, but you may not, your eye may not realize such a change of the images. Okay? Then the millisecond definitely we may not realize. However, computer changes the process such a millisecond level, so using certain selection criteria. So that is called a short-term scheduler. So whenever, however, this is not used right now a lot. Only few of the operating system or embedded system or old system. Mostly when we talk about the scheduler, that is the short-term scheduler, this one. So this is called sometimes CPU scheduler. So in this class, we mostly discuss later about such a CPU scheduler. Quick question. What can be the selection criteria in the process scheduling? If you are asked to develop the CPU scheduling algorithm, how can you develop?
How complicated it is?
How do you implement? What will be your idea to select the process from the ready queue? Priority. Before that, the most popular, first come, first serve. Like when you form a line in front of my office, first come, first serve. Okay? So it is the same in operating system. You will see later a lot of algorithm used in the operating system is the first come, first serve. Why? It's fair actually. First come, first serve is fair and also simple to implement. We can just use such a queue structure. Who provides such a queue structure? You can make by yourself. or system, operating system provides such a data structure. You don't have to implement it by yourself. Like the message queue, later we will see the message queue is already implemented by operating system. System as a system library. Or even your program language provides such a data structure, so we can easily follow such the data structure, then use it. So very simple to implement. And also, it's reasonably fast enough to use. As you know, such a queue is fast and stack is also fast data structure. So that is the reason first come first serve is most popular. But as you said, not always the first come first serve is fair, right? I need only the few milliseconds, okay? But sometimes you need to wait 2 hours, 3 hours. So if we apply the first, so there are different algorithms. So we will discuss this one more detail in chapter 5, the CPU scheduling algorithm. So from now on, when we talk about the scheduling, or the CPU scheduler, that is the short term. There is another one, the midterm. It's not very important, but the midterm means, so once process is selected by long-term scheduler in case, then there's no way to take out one of the process until terminated. So if the one of process is running forever, really long, so the other process cannot get the CPU resource. So in the middle of process, if we need to select another process, then we can temporarily move out, take out from the memory, and save this one into the secondary storage. Okay. Then later, when we have the available memory space, and load it again. Okay, in the middle of process. So this is called the swap in and swap out. But this is swap. So there's the reality show. The wife swap. So we can exchange it, but usually it's not good. So we can swap in and out. Question: do we use the swap in and out in our current operating system? Yes. No. So swap is a good, fast, efficient operation or not? It's very, very expensive because we need to copy all of them and load it again. So it's very expensive. It takes a time. So we do not use this one completely. No. Sometimes we need. So instead of swap in and out entire process, we can partially in and out. That is called the page in and out. It's a small unit data structure in the memory. So later in the memory management, chapter 8 and 9, we will discuss about such a page in and out and the swap in and out. That is called the midterm scheduler. However, current operating system, general operating system, do not use a lot such a midterm and short term, a midterm and long term, because it's a very, very expensive operation, costly. Instead, we are focusing on the such a short-term scheduler. Details we will discuss in the chapter 5. Okay, then we are ready to use the CPU resource, the process, and how to manage the multiple process and so on. The problem is we don't discuss yet the how to start, how to load such a process into the memory, how to create the process. So we are going to discuss about how to create. Finally, how to create. So whenever we need to use the hardware resource, operating system provides a very nice interface, that is system core or system library. Okay, we can use the system library. If you do not remember what is the system library, and check your previous page, we learned about the 200. We didn't check each and everything, but you can find such a system library, system code. So if you check your system library, like the POSIX API or Windows API, so there is a command or the function to create the process. Before that, there are different types. There is the basic mechanism how the process will be created in the operating system. That is, as I mentioned briefly here, first process will be created. This is the kernel process, usually called the init process. This init process will create system processes. For example, scheduler. Scheduler will be processed. And the swap will be processed. And the network will be processed. And system process. Then this one create another one, and another one, and finally this is a shell program. So from the shell program you can run ls command. That is a process like that. So it's from the always the pattern create the children processes. Then each of them, and so this is a physical memory. This one will be here, this one will be here. All of this process is in the memory, like this one. Okay. Then when a process creates a child process, there are three different ways. One is, first, parent and child are exactly same, share everything, which means, so this process is, let's say this is process ID 1. When this process creates a child process, let's say this is a 10. 10 is also share all the resources. Okay? Then if needed, update. Like here in the United States is slightly different, but until the high school, most of the time the high schooler, before going to the college, you live in your parents' house, right? And but anyway, even though you have a room that belongs to your parents, right? Share everything. Okay. Then this is the same thing in the process. You can share. Problem? It's so good for what? Utilization, because you share. Okay, you don't have to pay your mortgage. You don't have to pay the utility fee. Just live with your parents. That is the best way. Second thing is, some of the resources share, the others are not. Okay, so you can partially pay, like to your parents. I'm not sure, but some of the parts. So not all of the parents. 10 has their own, but the other share with the parent. Because this process creates the child process. Some of them are identical, so we don't have to create separately. Third, another approach is separate. So like there's no share. Okay. So problem of this is you need more resource and takes time because you need to create the memory space and the copy all the program, and it's separated. So it's a cost and takes some time. So depending on the operating system, it may be different. So however, most of current operating system that we